probability. So here's the way you do probability. Simply, it is going to be the number of ways to win. Number of ways to win over total ways. It's as easy as that. That's probability. So, if we take a dice, okay. Actually, we'll start with the coin. The coin's the most basic, right? Of course, I don't have a coin because Landon probably takes all my money. So let's see if I did. Okay. Oh, I do have some pennies. He doesn't care less about the pennies. Okay. But we all know, if you have a coin, there's, if I said I want to flip heads, there's one heads out of two possibilities. So it's just as easy as that. So on a heads, so the probability of heads is just going to be one head out of two possibilities, right? One out of two. It's that easy, okay? And then the same thing with dice. If I want to roll a 6, so if I want a P of a 6, so if I want P of a 6, to roll a 6, there's only one 6, right? There's only one 6 out of a total of 6 possibilities, right? Cards, right? Cards. I want the probability of, say, a king. I want the probability of a king. There's how many kings in the deck? 4 out of 52. It's that easy. And of course, you can reduce it. You can change to decimal. Everybody good? Thumbs up on how probability works. Okay, everybody? Girls in the back, you guys good? Probability makes sense? Marilia? Okay, good. So now, we talk about the idea that there are, first of all, mutually exclusive events. So exclusive events are going to be events that don't affect each other. Now, they go through less than 3 and greater than 3. Both these events are completely separate, mutually exclusive. Something that would be not mutually exclusive would be, for instance, if I drew 2 cards. Okay, if I wanted to draw, for instance, if I wanted to draw 4 kings in a row, my first draw will definitely affect my second draw. Because once I pull a card out of the deck changes, right? So that is not mutually exclusive. I want to pull another king out, my deck's changed, so that the second draw affects the deck. Does that make sense? So some things are not mutually exclusive, but rolling less than a 3 and greater than 3, those are totally different. You cannot do both, right? You can't do a roll and have one. You can do one or the other, okay? Complementary events, okay? Complementary events are events that are mutually exclusive together, but they include all possibilities, okay? So this means all possible ways, okay? So the example they say is less than 3 or greater than 3. So if I say roll, ready? Roll, Mr. Davis, something greater than 3 or less than 3. I can't lose, can I? Okay, I'll say it again. Mr. Davis, roll something less than 3 or greater than 3 or equal to 3. I can't lose because that's all the possibilities, right? Okay. Odds. Now, odds are different because it's odds to win versus odds to lose. So odds are different. So if I wanted to roll, ready? If I wanted to roll a 6, odds. So the odds of me winning in favor is 1 out of 5. 1 out of 5. The odds, okay? So the odds of rolling a 6 on the dice, there's only one way to win, but there's 5 ways to lose. That's odds in favor, okay? Odds against, because you're betting against me. You got me. If you're going to bet against me, I would, because my chances are slim, aren't they? I got a 1 out of 5, 1 to 5 odds of winning. You're going to bet against me, so odds against for you guys would be 5 to 1. See the difference? You're going to say, I have 5 chances of you losing, right? So I'm going to those. Okay. So the odds against are 5 to 1 because I'm probably going to lose, right? There's 5 ways for me to lose versus 1 way for me to win. Okay. So you see the difference between odds and probability? And odds, quite often we write like this. Okay. We write with a 5. So you've got a 5 to 1 odds against. So when you see the horse races, I don't know if you guys ever watch like the Kentucky Derby or anything like that, and they do the betters. They do it on odds. And sometimes you see a 2 to 3 odds. What does that mean? At 2 to 3 odds, that means I've got 2 chances to win, they think, versus 3 chances to lose. Now those aren't great odds, but they're better than some. But if you see odds like 3 to 2, 3 to 2 in favor, if I've got 3 chances to win versus 2 chances of losing, those are pretty good odds, right? I have a chance. I have a better chance of winning than losing, okay? Everybody okay on odds? Odds of chances of winning versus chance of losing. Probability is different. Probability is like the whole set, right? So if a probability, it's 4 out of 42. If this were an odds, I'd have 4 out of 48 for odds. For odds, if this were odds, it'd be a 4 out of a 48. I have 4 chances of drawing a king versus 48 chances of not drawing a king, right? That's odds, okay? You guys ready to turn the page? So far, so good. Okay, now, let's scoot down to 1, okay? Each letter of the word mathematics is printed on a separate card. The cards are shuffled and one is chosen at random. Find the probability. Now the probability, okay? So first of all, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 possible choices, okay? There's 11 possible choices, okay? How many vowels? 1, 2, 3, 4. So my probability is 4 out of 11 to pull a vowel, okay? So it's probability is how many chances to win. There's 4 out of the total. That's probability, okay? M or a vowel, okay? So it's still probability, so I have 11 choices, right? I have 4 vowels plus how many M's? I have 1, 2 M's, right? So that means I'd have 6 out of 11 chances, right? I've got my 4 vowels, so I've got my 1, 2, 3, 4 vowels, and I've got my 1, 2 M's. So my probability to win is 6. That's the chances to win out of 11, which is my total, okay? Now, next one talks about probability with cards, okay? A red or a red face card. Now, sometimes there's some fancy forms, but sometimes I think just doing common sense. So how many red cards are there?
It's half the deck.
Okay, it's half the deck, so there's got to be what? 26. So we got 26 red and a face card. Now, face card are going to be all like king, queen, jack, right? They've got a face, right? Does that make sense? Face cards, they have a face. Like king, queen, jack, face cards. So now, how many face cards are there? 12, right? But some of them have already been counted here. You agree with that? Okay, so then there's 12 face cards, right? But some of these face cards have been counted here. So how many face cards can we add to this?
6.
Right? Because we got 2 black kings, we got 2 black queens, and 2 black jacks. So we go plus 6, right? Which makes what? 32 out of what? We're doing probability. How many cards in the deck?
32.
Okay. Am I going slowly enough so this makes sense? How many ways can you win? Well, there are 32 cards that are either red or face card, okay? Out of the 52, okay? Okay. Red and a face card, okay? Probably a red and a face card. Now that's different. How many red face cards are there?
6.
There's 6. Because you have to have both. You have to pull a red and it has to be a face card. Okay, does that make sense? If I have to pull a red, so that means I could pull out the 2 kings, I could pull out the 2 queens, I could pull out the 2 jacks that happen to be red, right? So that's just 6 out of 52. Does that make sense? I did that? Okay. So sometimes probability can be pretty easy if you just think about it. Okay. Now, a diamond or a heart.
It's just 26.
Okay, 26, right? I mean, there's 13 and 13, so 26 out of 52, or 1 out of 2, right? You guys agree with that? Now, what about a black or a king? Okay, how many black cards are there?
26.
26. And then how many kings are left that are not black cards?
2.
2. So that's the 26 plus 2, right? There's 2 kings that are not black, right? So you get 26 here plus 2 red kings, because the other kings are already counted in here. Does that make sense? So you get a 20. 8 out of 52, okay? All right, so probability. I'm almost done. Probability. Ways to win. How many ways do you have to win out of the total? That's probability. Odds. Odds that favor, or how many ways can you win versus how many ways can you lose? Odds against, how many ways can you lose versus how many ways could you win? Okay, that's odds. They're different, aren't they? So let me quit this and